Hi everyone, Dankman here. So this is the second example of factoring quadratics with a common factor, and the introductory video has a lot more explanation. I'm not going to do that explanation here, so this is a good video to watch after the intro video, and maybe after example 1 if you want. So when I look at this quadratic, and the instructions are please factor this quadratic expression completely, okay? The first thing I notice as a factor is if there are any common factors inside of each term. And I can see a 3 hidden inside of the first term. I can see a 3 hidden inside the second term, which can be rewritten as 3 times negative 11x. And I know it's a big one, but 3 times something, I know there's a 3 in 72. I may not know 3 times what, but I happen to know that 72 can be factored as, for instance, 9 times 8, and there are 2 3's inside of 9. So I know there's a 3 somewhere inside of 72. Or, you could think of it as 6 times 12. I know there's a 3 inside of 6, and there's a 3 inside of 12. So even though I don't know maybe necessarily off the top of my head what 3 times what goes into 72, I know there's a factor of 3 somewhere in 72, so I know there will be a common factor of 3 inside of each different term. And if you really can't figure that, go ahead and do 72 divided by 3 and put it in the calculator. I think we'll get 24. Okay, so I'm going to undistribute a 3 because I found a common factor, and that means I can rewrite this problem where I multiply 3 times a whole group, and that group is going to be the leftovers, x squared minus 11x plus 24. So I've now factored out a common factor, and when I look at this, I can see that this second factor, the group x squared minus 11x plus 24, is a quadratic that can be factored by this pattern we discovered when we were multiplying our binomials, where we know we can play a little x game, and we're looking for these 2 mystery numbers. So I'm going to take that purple underlined quadratic, and I know I'm going to factor it into x and a mystery number times x and a mystery number. And these 2 mystery numbers that go here and here in my binomial multiplication are going to come from the product. So these 2 mystery numbers have to multiply together to make 24, and the sum they have to add together to make negative 11. So they have to add to negative 11 and multiply to 24, and when I find those mystery numbers, I can fill in the missing parts of my 2 factors. So I'm looking for 2 numbers that multiply to positive 24 and add to negative 11. So I might try, 2 times 12 makes 24, so those are 2 factors that could be my mystery numbers, and if I add them together, they make 14. And that's not right, because I need to add to negative 11. So I could try negative 2 and negative 12, which would give me negative 14. So I'm on the right track here, because a negative 2 times a negative 12 will give me a positive 24. And when I add them together, I do get a negative number. But it's not quite the right sum. So I'm going to go now instead for 8 and 3. 8 plus 3 would give me 11. Negative 8 plus negative 3 does give me negative 11, and negative 8 times negative 3 does give me positive 24. So my mystery numbers are negative 8 and negative 3. And that's just an x game. And those are fun puzzles to play, so practice and play them as much as you can. And that means my mystery numbers are going to fill in those blanks there. And what have we accomplished? We took this expression, 3x squared minus 33x plus 72, and the question is, can we factor this completely? The first thing I noticed was that there was a common factor in each term, so if I undistributed a 3, that factored this whole problem into 1, 2 factors. Then I noticed that this quadratic factor that was left over could be further factored into a multiplication problem of x minus 8 times x minus 3. And just to check my work, just to keep myself clear on what I've accomplished, I'm going to re-multiply this problem out and see if it lands me back where I started. Because if it doesn't, that means I didn't factor it correctly. And so the first thing I'll do is I'll unfactor x minus 8 times x minus 3. So in other words, I will multiply those 2 together, okay? remembering that I first have to distribute the leading x, so x times x, and then x times negative 3 is minus 3x, then negative 8 times x, negative 8 times negative 3, and then simplifying that, I get x squared, minus 3x, and minus 8x is negative 11x, so there's my sum of negative 11, and minus 8 times minus 3 is my product of positive 24, so that's undoing the little x game. Then distributing the 3, I'd get 3x squared, 3 times negative 11x gives me negative 33x, and 3 times 24. And 3 times 24 would give me 72. And so, just checking, this problem here, this expression, 3x squared minus 33x plus 72, is what I started with. Perfect.